we're going to do a solution unit conversion problem. We're given the mass percent of the solution, and we're going to convert it to molality. This is a common thing to have to do in lab because when we buy solutions, they'll come in one concentration unit, but we may need the concentration unit to be a different one for the purposes of the experiment. Let's work on some definitions first. We're given the mass percent. So what's the definition of mass percent? Well, it's part over whole. What's the part? What's the whole? The part is the mass of solute, which for this problem is HCl, because it's HCl dissolved in water. And the whole is the mass of the solution, the whole thing. And since it's percent, we multiply it by 100. Percent means out of 100. Molality. Well, we've done that. What's the definition of molality? Moles of solute divided by the mass of the solvent in kilograms. Well, there are definitions. We don't seem to have a whole lot of information. I mean, as far as numerical information, that's all we're given. Well, so let's start with that and see what we get. What's the mass of the solution? You can pick anything at this point, but you should pick a mass that makes the problem easier to do for you. And since we're given the mass percent, percent implies out of 100, so why not pick a solution mass of 100 grams? I went to 1 decimal place on my solution mass because my mass percent goes to 1 decimal place. So I just matched it up. What did we say the solute is? Well, it's hydrochloric acid. And hydrochloric acid is HCl dissolved in water. So that makes HCl the solute. And we're not told how much we have in grams, but we know that 37.0% of it is HCl. Therefore, since we chose 100 grams for our solution mass, that makes the solute mass easy, 37.0 grams. What else is in the solution? That would be the solvent, which is water. We aren't told the mass of the solvent. But you know the mass of the solution. The solution is everything. We know the mass of the solute, which is one part of it. Therefore, the mass of the solvent must be what's left over, 63.0 grams. Okay, let's go look over at molality. We need the mass of the solvent. That's supposed to be in kilograms, but we can do that. That's easy. Kilograms to grams. We've already done that. We need the moles of solute. Well, we don't have that. We have the mass of the solute. Well, we've done a molality calculation before. What's the link between mass and moles? Molar mass. Let's start the problem. I just shifted things up because I needed more room. Well, let's start this like we started the molality problem before. Let's do that first. Let's calculate the moles of solute. We're given the mass, so we have to convert to moles. We do that using the molar mass. just like before. Unit check. All right, we have moles of solute. Now we divide it by the mass of the solvent. But we know that has to be in kilograms because the definition of molality. Do a unit check. And let's see. I think we've got everything. Let's check. So we have moles of solute divided by kilograms of solvent. How many significant figures in our answer? 3. So we multiply and divide, and we get 16.1 moles per kilogram.